Starting. So please welcome Idan Gazit, who will give us a talk about data design meaning.
Hello, ladies. Yes, unfortunately, I kind of lost my voice, so I'm going to be giving. There's requests for more volume. There we go. I lost my voice, so I'm going to be giving my talk in like a Barry White, like smooth, quiet. But it's not for lack of enthusiasm. It's simply for lack of, voice. So yes, please bear with me, and my apologies. Hi, so I'm Idan, and if you don't know me, I'm Django's benevolent designer for life. And for my day job, I do Skills, which is my awesome startup for hiring. And if you're hiring, you should totally use us, especially because we're still free because we're in beta. So yeah, tweet us for an invite, and I'll be happy to let you all in. No? Better? Okay. Right, and I really love visualization, partly because it's a little bit of a mirror of myself. I'm an engineer and a designer, jack of all trades, master of none, et cetera, et cetera. So it's a reflection of myself, and that's why this is a subject that's really close to my heart. And I've given a lot of talks about design for developers. But this is probably the one that's really most important to me, so I hope you guys will like it. Right, so visualization, right? Taking data and extracting meaning. This is still very much the province of humans. You're never going to be able to import visualization and be done, because deriving this middle step requires creativity and empathy. Right. Ben Fry, who is famous for inventing the processing language, if you've ever heard of it, which is a great way to do sketching of visualizations, try things out. It's very cool. Came up with these, the 7 steps of visualization. Python is the perfect language for the first 4, but I don't have anything interesting or unique to say about the first 4 that other people haven't said before me better. So I'm not actually going to talk about the Python parts. I'm going to talk about the design parts, because I suspect that's rare or more interesting to this crowd, and how to take, once you already have your data and you already have the story and the narrative that you want to tell, how do you best go about explaining that story to others? Right, so yeah, so what is a visualization exactly? Visualizations are more than charts. Charts are a subset of visualizations. All visualizations supply meaning through the visual display of information. But charts tend to be one-dimensional. Time series data is 2-dimensional, but a good visualization can be highly multidimensional. It can encode a lot of different kinds of information into a very compact kind of space. This graphic is widely cited as one of the pioneers in the field of data visualization. It was created by a French engineer called Charles Minard in 1869, and it shows the size of Napoleon's army as it marched to Moscow and back, and how balls freezingly cold it was on the way there and on the way back. And this was the first time, or at least the first popular time, that a visual means that was not strictly a chart was used to show and derive some useful meaning about something. So yeah, this one is very, very popular. Another popular and excellent visualization is the periodic table of elements. Also, coincidentally, in 1869, by a gentleman named Dmitri Mendeleev. It organizes the elements in a particular way, sorted by atomic weight, grouped into groups by various properties. And it provides structure through proximity. Elements that are proximal to one another probably share some interesting properties. One such group is the noble gases, for example. And here we have, one group on the side. They're called the noble gases because they tend to be chemically unreactive with other elements. And they happen to occupy sort of, this one space inside the table. So, yeah. But this table has a bunch of other interesting properties. First of all, if you know the properties of two adjacent elements, you can make some educated guesses about the properties of the elements in the middle. And actually, this was used to postulate the existence of elements that were as yet undiscovered when this table was laid out. This gap in the table, people said something has to be there, and it probably has some properties that should go between these two elements. And then they discovered this whole series of elements. So that's a whole lot of meaning that was absent when these elements were just a list on a piece of paper. So this is another fantastic visualization. Something more modern. This is something called a porcupine chart by Amanda Cox at the New York Times. And this shows actual versus projections of our budget deficit / surplus over time. And it interestingly shows at any given point in time how we thought we'd be doing in the future. And the cool part of meaning here is it shows this layer of meaning of how optimistic or pessimistic were we at any given time, which is another really cool dimension of information that's absent from just a regular time series data. So yeah. Right, okay. So you want to make one of these, and you have some data, and you might have a general idea of what kind of story you want to tell. So what now? First, you need to come up with like a really simple idea, right? Find a one-sentence description of the story, the narrative that you want to supply to your audience, saying, I want you to understand, blah, blah, and blah. So it has to be small enough to fit into one sentence. If it isn't, it's probably too complicated, and it'll be difficult to get across, or it'll be difficult to build a good visualization that doesn't get like lost and muddy and all over the place. And you might not have a good idea of what it is you actually want to talk about or show. You might not know your story until you've gone through the first 4 steps. It's okay to look at raw data and not have a good idea. It's only through working with that data do we have usually a good idea of what narratives we can extract from that data. So the key thing is to have that narrative firmly sorted in your head before you advance to the design phase. And before you advance to the design phase, there's actually a bunch of bad things that you should know not to do, right? First, do no harm, even inadvertently. You have all this data. It's tempting to throw it at your audience and let them figure it out and sort it out. Don't do that. It's bad. Resist that temptation. If the data that you want to show your audience isn't in service of your meaning, don't show it. And obviously, I'm not talking about cases where you like hiding some data because it's not good for your paper or your talk. I'm not talking like don't be dishonest. But if the data isn't like directly supporting your narrative, think twice before including it in your visualization. And in fact, the sentiment extends to almost everything. Think twice about including anything. It's really, really easy to add. It's very difficult to subtract. So. Yeah, this is always a good rule to live by when building anything visual. Edward Tufte, who's famous for a lot of reasons, and you should Google him and read his books because they're great, coined this phrase called the data-to-ink ratio. This was back before pixels. And the idea here is, for every droplet of ink on your page, for every pixel in your visualization, how many of those droplets, how many pixels are conveying meaning, and how many could you remove without changing the meaning, right? The perfect visualization, the ideal visualization, has a data-to-ink ratio of 1, where every pixel conveys meaning. And if you took it out, it would change the meaning. Obviously, these don't really exist. But it's a very good principle, and it's something you should always keep in the back of your mind. And here's a good example. This is a chart by out of one of my favorite books called Designing with Data by Brian Suda. And he illustrates this data to ink ratio thing very, very nicely, so I'm using his charts. This is a chart. It's a simple chart. It's not actually a very bad chart. It's clean. There's nothing truly, truly unnecessary about it. But there's a lot we can even improve about this. First, we don't actually need the axis lines to be as bright and as prominent as they are. We can tone them down. We're not actually removing pixels yet, but since we're making them less visually prominent, I think this counts. So yeah, so gray things out, de-emphasize them. And some of them you don't actually really need, right? We could get rid of a lot of those grid lines without changing the meaning of our chart. And here already we're emphasizing the natural range of the data better, instead of showing like the empty lines between 0 and 32 where our data starts. And in a lot of cases, you don't actually need the lines themselves. Gaps work just as well as lines when it comes to communicating something. Our eyes are very good at completing patterns. And so you can use gaps in lieu of adding more pixels to demarcate different sections of data. And compared to the original, this is a much clearer, and in my opinion, much more attractive chart. By removing just a couple of lines, by removing a bunch of pixels, we've made our chart better. This is a great example of how to improve the data to ink ratio of your visualization, even for something as simple as just a chart. Right. Unfortunately, this is what's in our newspapers, right? Where like the data to ink ratio is like asymptotically approaching 0. And there's a name for this, also coined by Edward Tufte. This is called chart junk. Avoid chart junk. If you want to illustrate your bar charts with like little graphics of whatever, like stacks of dollar bills, don't do that. Okay. It doesn't add any meaning. It makes your data harder to process. It makes it harder to compare. Just stick to plain graphics. Your users will thank you. Right. So let's assume that you care about your audience and you're not going to inflict any of that crap on them. Right. There's still a few ways that you can shoot yourself in the foot. This is a pie chart. Pie charts are bad for a lot of reasons, but I'm going to ignore that for a second. You've all seen these in like Apple's keynote presentations, right? These wedges are actually all the same size, even though the perspective serves to distort this pie chart and show you that the bottom wedge, the one that's closest to us, appears larger than the top ones. This is worse than chart junk. This is lying. So yeah. Even though like Keynote and Excel let you do this, resist the temptation. Don't do this. Keep it clean. A bar chart would actually serve you far better. And because we're a lot better at comparing heights of things or widths of things, then a bar chart will also allow people to more easily see and compare the different values compared to, say, a pie chart. Right, so don't do any of this stuff, and if you forget everything else I'm going to say from here on out, those principles will keep you on the right track when you're displaying information for people. Okay, so by definition, all of the people who are going to be taking your visualization in are taking it in through their optic nerve. So it behooves us to know how vision works, because we can use all sorts of things about perception and vision to our advantage when delivering this information to people's optic nerve. Gestalt theory arose in like the 1800s, and it says loosely, poorly, I'm probably distorting this horribly, that vision is more about, or it's less about how we perceive individual elements and more about how we perceive the relationships between these elements and the context in which we perceive these elements. And more often than not, meaning is about relationships. And from the moment we're born, from the moment we open our eyes, from the moment we're babies, until now, we are constantly training to ascribe relationships and properties to visual things. And these are 6 different ways in which our eyes train from birth. So you should use these to your advantage. Proximity, we think that things that are proximal are grouped. So here we have 4 groups of 5. Similarity, similar things appear grouped to us. Enclosure, things that are enclosed by another graphical shape appear to be a group to us. connection, obviously. Continuity is a little bit more interesting. Here, we don't perceive this as 4 lines meeting in the middle. We perceive this as 2 lines crossed because they're continuous. And closure is probably one of the most interesting ones. Here, we don't perceive this as 3 shapes. We perceive this as 1 incomplete rectangle. Our brain completes the shape for us, and it does this for a wide variety of shapes. And that's a really cool aspect of perception, and you can use this to your advantage. And in fact, that's what the whole gaps in the charts thing, like, it's because of that. This is what makes it possible. But there's a couple other really cool things about perception and our brains. We're very good at judging horizontal versus vertical orientation of things very, very quickly. Like when you look at this, which one is unsafe to step on? Okay? It jumps out at you right away. You don't need to think about it. We're less good at comparing things that are at an angle that's not like 90 degrees. If I asked you to sort these by their angle, it's not that you couldn't do it, but you'd have to turn on like 100% of your like brain CPU to like accomplish this task. Whereas like this was effortless and immediate. So the obvious implication for visualizations is you shouldn't be asking people to like make quantitative comparisons based on things that are like angled a little bit more or a little bit less. Like if you've ever seen like gauges, like a lot of gauges one next to it, don't do that because it's hard. If you need to like compare like what the angle of the needle is, that's a very bad way because it's very hard to compare them one to the other. Find a different way to show that data. Shapes. We're actually very good at telling shapes apart, but only above a certain size and below a certain density. As soon as the size gets too small or the density gets too large, we have a hard time picking the shapes apart. Like if I want to see all the circles in this, it's not that I can't do it, but again, I have to turn on more of my brain to accomplish that. And this is actually something where color can help us. Notice that as soon as you apply color, it becomes immediately obvious, where the circles are, where the squares are. This is a really cool effect. In fact, color is special for a few different reasons. Perceptually, color is what's called pre-attentively processed. It's actually like on the way from like your optic nerve to your brain, like it's delivered with the color information already decoded, like as a present to like your brain. So you don't actually need to think about it when processing color. So yeah. So again, like in comparison, look how easy it is to pick apart the different shapes when they're colored as opposed to when they're not. And that's because our brains just do it automatically for us. Yeah, so color is a really neat tool, and it's also neat for visualizations because it's often the easiest way to add another dimension to your visualization. You even take the simplest time series data. If I add some color to it, I've added another dimension to it. I can add a whole other axis of information. And in fact, poor color rendering on this projector notwithstanding, you can encode more than one dimension in information. You can actually use color to encode 2 dimensions, and in some very, very rare instances, 3 dimensions of information by varying along hue and the value or brightness of the color. Here I'm using like a red-blue spectrum. If you want to generate these spectra on your own, you need to understand a little bit more about how color and physiology work. So in our eyes, we have these things called cones. And these are the things that sense color best in our eyes. And they come in 3 varieties, short, medium, and long. And they tend to perceive their associated color best. So the short ones see blue, the medium ones see green, and the long ones see red. But they have some overlap. And so scientific theory, like they overlap like which spectra they sense. Now scientific theory says that because they have this overlap, that actually what we perceive, or at least how our brain is recording this information, it's not actually as like 3 separate streams of information of like, the short, the medium, the long, the red, the green, and the blue. But actually, it's recording them in an antagonistic fashion. that the red and the green antagonize one another. So you can't record both red and green. And that's why there's no such color as reddish green. And there's no such color as yellowish blue. These colors don't exist because our eyes don't actually know how to represent this to our brain. We're actually recording the differences between these colors, red and green, and yellow and blue. And actually, the most common form of color blindness is a defect in one of these antagonistic pairs. 1 in 10 men in this room see the red and green like this. There's other forms of color blindness, but they're exceedingly rare. Right, and actually there's another opposition, which is light versus dark. Right? So we have these three opposing color pairs. And our brain records the information coming out of these three channels as lightness, and we'll call them A and B. And there's a standards body for color. They're called the CIE, and this is what's called the LAB color space. And it's the most interesting color space and the one that you want to know about when you're doing visualizations and mapping out colors and generating spectra, because it's the one that most closely maps on to how we perceive color. So yeah, lightness, A and B. Unfortunately, the math for generating LAB spectra or any kind of color space math in LAB, when it was invented in the 70s, it was computationally intensive. So we came up with two poor man's versions of LAB called HSL and HSV, hue, saturation, and lightness or value. These you're probably familiar with. They're in a lot of graphics programs you can choose. Except they're not exactly as good as LAB. They're easier to understand. Again, sorry for projector, but if you look, the original image is the top left. Just the lightness channel, the L channel in LAB is the top right. And the L and V channels are bottom left and bottom right, respectively. And you see that the lab color space rendition of just the luminosity is actually the best approximation of the original image when you reduce it to black and white. And that's why this is the color space that if you're going to be doing any kind of generation of color spectra for your visualizations, you should be working in LAB. It's 2012, our computers are strong, they can do this effortlessly now. There's really no reason to do the other two. So yeah, find yourself a good library. There's even a couple for Python. Import it and use it. Okay, yeah. It gets a lot deeper than this. And choosing colors is hard, but fortunately there's a shortcut. If you don't want to actually go out and generate these spectra yourselves, you can use what's called Brewer palettes. Somebody went and did, Cynthia Brewer, went and did some science on the matter and came up with a bunch of pleasing spectra that are easily distinguishable, like sets of colors. And even different ones that work for colorblind people are things that will come out in a photocopier when reduced to black and white. This website I think is colorbrewer2.org or something like that. Google it, you'll find it. And you can just take these spectra and use them without generating them yourself. It's a good place to start. Right. So, okay, color, that's great. Now you have to actually lay out and present your information to your audience. The most important thing when you're presenting your information to your audience is to establish a visual hierarchy so that you're not shouting at them in a monotone. If all of the elements that you're displaying have the same visual weight, it's just like that. It's shouting in a monotone. Nothing is more important than anything else. And that's a bad way to guide the reader's eye around the page. It's a bad way. It impedes their ability to scan the page and look for what's interesting to them and focus in on that because everything looks the same. And you can create that hierarchy mostly through the addition and removal of emphasis. And actually, I like to talk more about removal of emphasis than addition. Normally, when people talk about creating a visual hierarchy, or you think, naturally, especially in the context of the web, like, okay, I have my body text, and things that need more emphasis, I'll just H1 those, and they'll get big and emphasized. And that's good for some of the time, but most of the time, what you really want to do is remove emphasis. So try to think about it more like that, where you have like normal size text and things that are less important. You remove the emphasis. This is especially important for visualizations where people are seeing your data often. If somebody's coming to see your data once, then okay, it doesn't really matter. But if they're coming to see your data once a day or several times a day, and they're seeing this data over and over again, usually the meta information, they'll need it at first, but they're not going to need it after the third time they see your data. And you want it to fall away visually and disappear so they can focus on the bits that are meaningful to them. But you don't want to remove it entirely because maybe somebody new joins the company tomorrow and they need to know how to get around and what these things mean. So yeah, removing emphasis is a great way to keep that information around but make it not smack your users in the face. A great example of this is, for example, if you're showing like a range, this could be 8 out of 10. You want to show what the range is so that people know what the range is, but you don't want to hit them in the face with it. So, de-emphasize liberally. De-emphasize almost until the point where it's not perceptible anymore, and then take it up just one notch so that it's just visible. Make it like the minimal perceptible difference. You'd be surprised how classy this comes out looking for almost all applications. And while we're talking about numbers, let's talk a little about typography and numerals. There are actually 4 different types of numerals. And those of you who aren't typography buffs almost certainly do not know this. So numerals come in 4 different styles. First, there's old style versus lining numerals. Old style numerals are designed to go in running text, where you have a mix of uppercase and lowercase forms. Old style numerals are supposed to mix in with that. They have sort of an uppercase and lowercase feel. Some of the numbers fit into the lowercase, up to what's called the X height, which is like the lowercase height. Some of them go above and have ascenders. Some of them have descenders, just like a mix of uppercase and lowercase text. And if you have running text, these are the kinds of numbers that you should use. But if you have numbers just standing alone, then you don't want this uppercase and lowercase mix because they generally tend to look awkward and out of place. And also, they don't fit neatly into boxes. Yeah, so for most visualization applications, like you're presenting big numbers, you want to use lining figures. Just use them. And for most good typefaces, they actually include this. All professional typefaces, and when I say professional, I mean like if you paid $100 or more for your typeface, then chances are it includes it. If you paid less, it might not. If you're using a service like Typekit, you can actually choose which fonts. If you're looking for a font to use on the web, you can actually select at the bottom there, you have a little selector, like show me only the fonts that have like uppercase or lowercase. And unfortunately on the web nowadays, for any given one font, it's still kind of like crappy and broken. You can't have like one font and have the ability to choose which ones, except in Firefox. But that doesn't really matter to you. Bottom line is use lining numerals for your visualizations, and you can choose which ones you want to use if you're using a service like Typekit. The other 2 kinds of numerals are proportional versus tabular. Most numbers are proportional, just like letters. An I is not the same width as an A. And the same goes for numbers. A 1 is not the same width as a 0. And that's great for running text. But it's not great when you want to like line them up in tabular fashion and sum them and show how they sum. So again, good fonts will have all 4 of these numerals and a couple more that I'm not even going to talk about now. So choose the right numerals to use. Okay, so you're displaying your data. It's pretty, it's nice. But it's 2012. We have the web. You can make your visualizations interactive, and this is like the hottest, awesomest stuff going on right now because it allows us to explore data in ways that previously we couldn't. Right. So you can show a lot more data when you make it interactive. But this is like so much rope that you can hang yourself with because you can show too much data and overwhelm your audiences. Right. And one of the problems that journalism is running into with all of these visualizations is, as they incorporate these interactive visualizations, is that they're overwhelming their audiences with information, and they're looking for ways to help their audiences grapple with, this deep pool of data. How do they help them navigate around this data? How do they still supply a narrative with this data? Because in the end, journalism is supposed to tell you a story. And especially on the web, where people can just decide that this is too much, and they click away in half a second. This is a particularly difficult problem. And there's this natural tension between, in interactive visualizations, between a reader-driven narrative and an author-driven narrative. Are they going to take you by the hand through this narrative? Are they going to let you explore it on your own? And how do they balance these two needs off in their visualizations? So Edward Siegel and Jeffrey here, there's the URL there at the bottom, published this fantastic paper. They're from Stanford. A fantastic paper about successful strategies for doing interactive narratives, what seems to work on the web, and how do you tell stories with data in an interactive fashion. And they identified 3 successful models. Right, the first one is called the Martini Glass. And it's an approach that's guided at first and lets you explore later. All right? You start out, very quickly they focus you into like a guided narrative, and they take you along like a track of like, check this out and check that out and look at this and look at that. And now you can go and explore the rest of this data. You're set free to twiddle knobs and push sliders around or do whatever you like. And explore this data. And this is a good way to do storytelling because it lets the authors take you on a little ride and then set you free to check out whatever's interesting to you. Interestingly, this is kind of the opposite of how classical journalism is written, where they do it the opposite, where they start out with this very wide mouth, and they add detail, and as they add detail, they're constricting and constricting the story until they get to like this guided narrative. And then at the end, they open up, they step back, and they're like, and here's a twist, and leave you with like the wow feeling, hopefully, for good journalism. So, ironic that in journalism now this is kind of like, the flip side. The second strategy that they outlined is what's called an interactive slideshow, where instead of doing this sort of holistic, like, start, constrict, open up, they do it in pieces for different sections of the story. So you have like an interactive slideshow. And on slide 1, they present some kind of data, and then they like set you loose to play with that data a little bit. And then on they advance to slide 2, they show you a different side of the story, and then let you play with that different side of the story, and so on and so forth. So this is another successful model. A third is what's called the Drilldown, where you're presented with sort of the lay of the land. When you first get to the story, you can see that there's maybe like, if it's something geographical, or maybe there's like events happening at different places at the same time, and you can choose which one you want to drill down into and learn more about. And here again, like the narrative is controlled at any one of these like fractal scales. But on the whole, you're able to explore where you like. And even if you choose not to explore anything, if you just stay at the top level, you can get sort of the lay of the land, and the author has the opportunity to show you what's the most important things, like highlights for every given thing that you could drill down into at the top level. In the end, all of this needs to be in the service of your audience. All these things that I've talked about. If you come across something where it conflicts with the needs of your audience, then ignore everything I've said and serve your audience. In the end, they're the ones that you're serving. Visualization is for them. So ignore convention. This is exactly why you should break rules for your audience. Right, so before we wrap up, I want to plant one more little idea inside your head. A lot of you are busy doing like the next big thing in whatever, right? A lot of different fields. But this is a field that is hybrid almost by definition. And there are a lot of different topical fields where they are rich in data but poor in understanding. And all of you are probably the kinds of people that know how to manipulate data, and they really don't. So I'd like to urge you to reach out to all these other fields, find projects where people are doing something and they have no idea how to like even approach this stuff. You can be like a massive game changer for them. And as somebody who is a hybrid himself, who like traverses these like design and engineering worlds, like I'm really not the best designer, and I'm definitely not the best developer. But because I speak both languages, I'm able to make a lot of impact. And all of you can do the same for all these other fields. So I urge you to go and like poke your nose into these other fields and see what you can do to help them visualize the data that they have. Especially fields where nobody knows how to code. Right. And when you look at the greats in these fields, most of them actually came from a science background. They learned the design stuff as they went. They collaborated with designers, and they picked it up as they went along until they got to the point where they could do the basic stuff themselves, maybe even proficiently and well. But yeah, they got to be good by starting out somewhere and migrating in the other direction. You can do this too. Don't be afraid. The design stuff, it's a discipline that is very much similar to engineering in terms of how you learn it if you just approach it that way. So don't be afraid of like the stuff that's on the other side of the fence. Go out, explore, and learn it. And thank you.
We have some time for questions if someone wants to ask something.
Everybody's hungry?
Do you have any good resources for learning how to better use color?
Wow. Better use color. I don't know. I need to like look through my bookmarks and see what I come up with. Like the problem with learning how to better use color is that like when you Google for it, there's like it's very hard to separate the kinds of resources that are like hard color science, like intense like math and spectra. It gets really deep. Like my mind starts to hurt whenever I start reading those kinds of resources. And it's hard to Google for like the resources that are more like pleasing color or whatever. They exist. I'll look them up. I have a couple like pinned or bookmarked or whatever, and I'll tweet them or I'll post them or something in a follow-up. When I post the slides online, I'll include like another slide with resources. Design for Hackers is a good book. Yeah.
Can you talk a little bit more about when to break the rules? You said that you have to listen to your audience, but are there certain kinds of things that the audience asks for that they shouldn't have? I mean, there's a lot of kind of apocryphal stories about people like, make it sparkle more, and it's like, no, you can't have sparkle because no one else will be able to read it. So can you speak to which rules maybe to break, I guess?
So, like all elastic clauses, it's elastic. It's one of those like, I don't know how to define it, but you know it when you see it. Generally, when users ask to like make things sparkle or whatever, like they're asking like what you want to do is you want to, if you have the opportunity to even engage your users, is like start asking like what they really want. There's a great blog post, which I think is probably the best answer I can give, by the developers of an iPad app called Penultimate. People kept asking for like eraser sizes. It's like a sketching app. And they kept asking for, like, I want to be able to like control like the size of my eraser. And what the developer did is they engaged their users, and they found out that what the users really wanted is a way to be more precise when they're like erasing in like a specific area, but be able to erase large swaths of stuff when they wanted to like erase that. So what they actually came up with is that the size of their eraser was dynamic according to the speed at which you moved you moved your finger or the stylus or whatever around on the tablet. And that actually answered the user's need, but it wasn't what the users asked for. So generally when users ask you stuff, what you want to do is engage them in a discussion to figure out what it is that they really need. It's very rare that they'll be able to like articulate that to you. It requires empathy to sort of like figure out, and so there's no one like pat answer. Generally, a good guideline is like the data to ink thing. If users are asking for things that violate that, chances are it's wrong, but like find out anyway. There's still a lot of times where you do want to violate it in the like service of your users, but it's like, depends on what you're doing.
Hi, this might kind of tie into the example you just gave, but one thing I hear from my friends who are on the design side of things is one of the problems we have with visualization is we came up with tools that make it really easy to do very fast visualizations really badly. Same thing with PowerPoint made it easy to do presentations really badly. And of course, as an engineer, the first reaction is, we'll make the tools better. Where do you see, is that really a path forward, making the tools better, or are there tools there that are good enough to do that now? Where do you see that going from here to make visualizations themselves better?
Bad charts in PowerPoint are never going to go away because business users love bad charts. The market incentives are wrong. They will never disappear. Unfortunately, the onus is on you to make sure to like not abuse PowerPoint. PowerPoint is not going to help you not shoot yourself in the foot. There are good toolkits out there for visualization, not charting. The one that I can recommend is something called D3 in JavaScript for generating like cool web-based visualizations. It is totally going to make your brain melt at first when you first like mess around with it. But once like you wrap your brain around it, it really blows your mind with what you can do with it. And it's all about like dynamic documents. So if you want to make like an interactive visualization, check out D3. I can't recommend it enough, and it's the only visualization toolkit that I think really deserves the name that I can think of.
And the developer and the community are very responsive.
Unfortunately, it's JavaScript. Sorry.
I just wanted to quickly echo what you were saying at the end about sort of the non-techie folks. I used to work for a short time with the Spatial History Lab at Stanford, so we're talking like history majors who are putting in enormous amounts of work, like they're going to like the Fresno County Records Office and looking at 100-year-old pieces of paper and collecting it all, and are stuck with some pretty bad tools to actually like put into their papers and realize all that effort. So you'll be surprised at how much you can do with just being a geeky guy. It's pretty awesome, and it feels really good too.
Yeah, it's awesome being like a rock star when they're like, "Whoa, I had no idea you could do that." So yes.
Yeah, I almost felt guilty sometimes. I was like, I'm not really doing anything special, but they're like, oh my God.
Yeah, I've had exactly that feeling on multiple occasions from exactly that situation, so yes.
Hi, Dan.
Hi, Jacob. How's it going?
So not to harp on charting, because we've talked about it a little bit, but I actually do want to go back to it because, so the example you gave on charts I think is a fantastic sort of walkthrough of like how to take something that we might draw and turn it into something that actually looks really pleasant and beautiful. But here's the thing, I'm a programmer, I don't actually draw charts. I use a tool that I feed data at a tool and it draws charts. And what's difficult, I think, and what I'm interested in your thoughts on is a lot of the decisions that go into going from that ugly version, which is what I get out of my tools, to the nice one involve aesthetic choices. And do you think it's actually possible for software to make those aesthetic choices to the point where I, as a programmer, can throw data at a charting library and get back something beautiful? Or am I always going to have to, is that always going to have to be a human decision about what to omit and how to distill that down into a more aesthetically pleasing graphic?
I'm going to give the cop-out answer and say that, yes, tools can improve a lot. A lot of what's crappy about tools, like you say, is like the charts that come out by default are like, even if like you're like a wizard with like how you set up the charts and whatever, they still come out looking, like the first chart. And then you have to go like the extra mile on your own and take it from like the first chart to the nice chart. I think that the first chart can be improved. And this is actually a good idea for like an open source charting project to like make charts not suck. And I might be completely sticking my foot in my mouth because maybe like it's actually non-trivial to like have a general purpose charting library that knows to do things like, okay, like omit this range and whatever. But I suspect that there's probably improvements that could be written if somebody so chose to author such a tool. But in the end, yeah, it is a lot of like aesthetic choices. But I don't think that they are difficult aesthetic choices. I think that like a small amount of training, even like this like series of examples that I showed, is like enough to get people started like practicing doing this with their charts. So that even developers that aren't designers can still do like, some basic operations. And maybe it won't be like, like the most beautiful chart ever, but they can make it like, they can get it like at least like 2 steps where like a professional designer could take it 4,
Thanks.
Hello. So it seems like a lot of design literature focuses on what you called once users who are so novice they prefer a single button on the device to any kind of interactivity. Can you recommend any reading or give any thoughts on how to deal with expert users who have, an incredibly deep knowledge of the subject area that you're visualizing and want a lot of control and a lot of information?
No, I can't think of anything that's like specifically targeted at power users. I mean, nothing's popping to mind at the moment. Again, I'll trawl through my bookmarks and see like what I can find there that like would be applicable. Usually, it's rare to like build things that are only for expert users. Even expert users, like the new guy comes in tomorrow and they're not an expert user.
It's a gene sequencer.
Okay, yeah, those are all expert users. There is, I'm sure, like if you look at like literature, like probably you want to like nose around like the fields of like cognitive science, like stuff by like Don Norman and like that area. I'm sure that they have some stuff that addresses like what do you do with expert users that are seeing this over and over again. I can't think of like a specific example, but like. My hunch is that that's where like that would live.
Yeah, that's great. Thank you.
Hey, thanks. You mentioned penultimate, so tonight, Matchbox, I'm the founder and CEO, designer founder. We're having the founder of penultimate in a discussion tonight about user interface. I wanted to see if you want to come.
What?
We're going to talk about. I'll tell you. So you should come though. It's a small group. We're going to get together, and anybody else who's really interested in user interface design or UX and just wants to come have a high-level discussion about, the topic.
Don't go away. I'll grab you as soon as I get off stage.
Cool. Thanks. Appreciate it.
Where and when? Say for everybody's benefit.
Well,
or not.
Come talk to me afterwards. I'll tell you where it is. We can't. Not everybody can come. A few of you can come.
Thank you.
Last question.
You talked about de-emphasizing as opposed to making everything bolder. And de-emphasizing to just above the point at where it was imperceptible, basically. And my concern when I heard that is how can I be confident that my information is still accessible? Because I know I've had the experience where I cursed the designer who thought that was still readable or whatever.
Okay, so yeah, I mean, look, for example, because I was unable to like get in here and calibrate my display, the contrast and the colors of my presentation were not awesome, and like some of the slides were like too dark or things like that. So that's a problem. And a professional designer will take that into account. They'll make it like not like one step. They'll take it like they'll take a little bit of like safety margin. So yeah, it doesn't have to be like right on the borderline unless you know that you have like a very controlled output. So again, knowing your medium, knowing your audience, knowing your context, all factor into like this discussion. But yeah, like your aim is to get to that, like, you know, as close as possible without bust.
Okay, thank you.
Thank you all, and please don't be shy. Come talk to me. I'm giving another talk not tomorrow, the day after, about sketching and product design, and you should all come because it's going to be awesome, and hopefully by then my voice will come back.